Okay, this is 4.3 talking about rectangles, rhombi, and squares. Remember, rhombi is just the plural of rhombus. Okay, let's talk about the difference between a rectangle and a square. A rectangle is a parallelogram that has a right angle. So the definition says it only has one right angle. So what does that mean about all the other angles? Well, let's think about it. So it's a parallelogram. So that means that opposite angles are congruent. And we know that adjacent angles or consecutive angles add up to 180. So this one plus this one adds up to 180. So that means that it has 4 right angles. Okay, so all angles of a rectangle are right angles. We also know something about the diagonals. So the diagonals of a rectangle are congruent. So now we can think about some stuff. So all rectangles are parallelograms. But now we have some parallelograms are rectangles. Okay? And then we can even get any farther and say some rectangles are squares. So what's important here is to recognize these words all and some. So every rectangle we talk about is a parallelogram. So it's going to have all the same properties as a parallelogram plus these additional 2 properties here. If we start with a parallelogram and then we go down, then only a few parallelograms are actually going to be rectangles because of these 2 properties. Squares are a different thing, and so taking these properties of a parallelogram and the properties of a rectangle, we have a few more properties that'll make it a square. And so a square is a rectangle that has 2 adjacent congruent sides. So what does that mean about all of the sides? Well, we know that it has 90-degree angles, 2 adjacent congruent sides. Well, that means that opposite angles are congruent, or opposite sides are congruent, which means that all of my sides are congruent. So all sides in a square are congruent. We know that a square has 4 right angles because that's a property of a rectangle, and we know a square is a rectangle. It has, again, we think about the properties of a rectangle. Diagonals are congruent. But we take this one step farther with our diagonals. Our diagonals are also perpendicular. So if I draw my square with my diagonals, these form right angles in here. We also know still that opposite sides are parallel, okay, because it is a parallelogram. So the only property that's unique to a square is that it has all sides are congruent. All of this stuff comes from a rectangle or from a parallelogram. Okay, a rhombus. A rhombus is a parallelogram with 2 adjacent sides. Now, if we think back to what it was for a square, it was a rectangle with 2 congruent adjacent sides. So maybe a rhombus is not a rectangle. So in this case, we know if we have 2 congruent adjacent sides, parallelograms, opposite sides are congruent. So let's draw a rhombus. It might look like a square, but it's not. So we have all sides are congruent in a rhombus. And still, when I talk about my diagonals, they're also perpendicular. Okay? So that's what when we talk about a rhombus. Okay? This does not mean anything about the angles in here. So if I draw another rhombus, oops, let's try that again. Okay, I know that opposite sides are congruent. I know opposite angles are congruent. But all of my sides are the same. So my angles here are kind of similar that to a parallelogram. Okay, the alternate definition of a square could say that a square is a rhombus whose adjacent sides form right angles. So we could say that we have our rhombus up here and that the adjacent sides, they form a right angle, right? Then it would have all the same properties. So let's just remind ourselves what the Pythagorean theorem is. We have a triangle here. We know that it's a right triangle. So our Pythagorean theorem again is a squared plus b squared equals c squared. Okay? So now take a minute in your notes and think about how we can relate a parallelogram, a rectangle, a square, and a rhombus, and how they might be connected in some way. And we'll talk about that again tomorrow.